Hello students, today we are going to see about Laplace transform problem in signals and system. The given question is x of t equal to t square u of t. So, we need to find out the Laplace transform. The general Laplace transform formula is Laplace of x of t, which is given by x of s, which is nothing but minus infinite to infinite x of t e power minus st dt. And here in the question they have given that x of t is t square u of t, right. So, we know that u of t value is 1 and that exists only for t greater than or equal to 0. So, wherever I have u of t, I can replace u of t as 1 and that value exists only for t greater than or equal to 0. So, I can write the x of t as t square into 1, which is nothing but t square, and this value exists only for t greater than or equal to 0, that is positive values of t. Okay, so t exists only for 0 to infinity. So, using this, wherever I have x of t, I should replace it by t square, but this value exists only for 0 to infinity. Okay, so using this I can apply in this formula. So, instead of minus infinity to infinity, right, this value exists only for 0 to infinity. So, I have to first change the integration limits as 0 to infinity. Then what is x of t? X of t value is t square and then minus st e power minus st dt. So, we have to apply the udv formula, integration of udv formula, which is nothing but uv minus u dash v1 plus u double dash v2. So, compare this, right. So, this value t square is nothing but u and this value is nothing but dv. Okay. So, here u is a t square and dv is e power minus st dt. So, find out u dash. U dash means differentiation. So, differentiation of t square is 2t. Again we need to find out u double dash. U double dash is nothing but differentiate this value, which is nothing but 2. Okay. So, again in this value we have v. So, we need to find out v value. So, integrate this, right. So, here we are doing the differentiation, here we are doing integration. So, integrate this value. So, integration of e power minus st dt is nothing but e power minus st by minus s. Again we need to find out v1. v1 is given by integrate again this value. So, e power minus st, already we have one minus s, again we have one minus s. Okay. So, this minus s is already there, again integration of e power minus st is e power minus st by minus s. Okay. So, v1 is nothing but e power minus st by s square. Okay. So, we have another term which is nothing but v2. So, for finding out the v2, again we need to integrate this term. Okay. So, what is v2? Again keep 1 by s square as it is, integrate e power minus st. So, e power minus st by minus s. So, which is v2 is nothing but e power minus st by minus s cube. Okay. So, this is nothing but v2. So, using these values, let us substitute here. Okay. So, I have to substitute what are all the values, uv minus u dash v1 plus u double dash v2. Okay. What is u? U is nothing but t square. And what is v? V is nothing but e power minus st by minus s. So, apply the limits 0 to infinity and then minus. What is u dash? U dash is 2t. And what is v1? V1 is e power minus st divided by s square. Again substitute the limits 0 to infinity. And next term it is plus. What is u double dash? U double dash is 2. Okay. And then v2. v2 is e power minus st by minus s cube. So, anyway, if we have only t u of t, we will use uv minus u dash v1 alone. Why? Because when we differentiate, u dash will become just 1. Okay, until we get constant term we have to differentiate and we have to increase the formula value, right. So if we have suppose t cube, right, we will use uv minus u dash v1 plus u double dash v2, and again we will use u triple dash and v3 also if we have t cube. Okay, so according to the problem we have to use the integration of udv formula. Okay, and then now apply the limits. Okay, so anyway when I apply infinity, right, so here it is infinity into e power s into infinity is nothing but infinity by minus s. Okay, anyway while applying the upper limit this value tends to 0. Okay, why? Because we have e power minus infinity is nothing but 0. Okay, and then apply the lower limit. While applying the lower limit, minus into minus it is plus. Anyway t value it becomes 0. 0 into any value is 0. Now apply the upper limit as usual. What is the value? Here it is infinity. Infinity into e power minus infinity by s square. Anyway again this value is also what? E power minus infinity, it is 0. Applying the lower limit, right, 2 into 0. Anyway why? Because t value is 0. Anyway this value is also 0. Okay, so all the terms so far it is 0. Okay, and again here also for the third term we need to apply the limits 0 to infinity. So we have plus 2 into, apply the upper limit e power minus infinity by minus s cube. Apply the lower limit, minus into minus will become plus e power minus 0 by s cube, right. So anyway again e power minus infinity, this value is also 0. Okay, e power minus 0 is nothing but 1. Okay, so this term becomes 1. So only that term is existing, so that value is nothing but 2 into 1 by s cube. Okay, so which implies the Laplace transform of t square u of t is 2 by s cube. Okay, thank you, thanks for watching.